Hello everyone, and welcome to this new video, which will be the first video of this new chapter. So in the previous chapter we saw Blender fundamental tools and concepts, but from this new chapter we will learn little more specific things which will allow you thereafter to manipulate a rig, that is to say to articulate a minis to create your own poses. So let's get started right away. In this first video, we're going to talk about the parents and children concept in 3D. To explain that to you, I will immediately create two objects. We will create a small cube and a small sphere. As you have guessed, since we are talking about a parents and children concept, one of our two objects will be the child of the other. Let's say the cube will be the child, and therefore it will have the sphere as parent. To assign a parent to an object, we can go to the Object Properties tab of the Property Editor, and under the panel called Relation, we can see a property called Parent. So we can define a parent object either with a list or with an eyedropper. Let's immediately use the eyedropper to get the sphere. And here, the cube has now a new property. It has a parent, the sphere. Amazing, isn't it? But what's for? Well, let's discover this together. If I move the sphere, so the parent object, here is the result. The cube will always follow the sphere. So the referential of a child is no longer the world, but its parent. So we can say that the child object now inherits transformations from its parent. So if I make a rotation, the child will also rotate, and we can see by the way that the child also inherits the parent's origin. We can see that the center of the rotation is indeed on the sphere, and not at cube's origin. And it's the same for all kind of transformations. If I scale the parent object, the child is also going to be scaled relative to the center of the parent's origin. And what if I want to transform the child object? Well, I would say nothing special happened. Everything behaves normally. We can continue to position, orient, or scale an object, even if it is linked to a parent. Besides, if we take a look at the transformation properties of our cube, we can see values are changing if I move, rotate, or scale it. On the other hand, if we memorize these values, and we will be able to do that thanks to the magic of editing, and then we move the parent object, turn it a little bit, do a little scale. The child object is also transformed, but then if we go back to check the values of the child object, we see that they are identical. Yet the object has been moved, rotated, and scaled through its parent object, but its values didn't change. This therefore means that these values, transformation properties of the cube, won't represent at all the actual position, orientation, or scale of the object in the absolute 3D space. As I said before, these values are no longer relative to the center of the world that we have here, but relative to the parent object. To show you this, I'm going to set all location values to 0. Normally, the object should position itself at the center of the world, but here the object will position itself in the center of its dad, or rather its mom. So the center of the world for a child is no longer the true center of the world, it is indeed the origin of its parent. If I also set all rotation values to 0, the object should become straight again, become horizontal again. But there, it is tilted. Why? This is because its parent is inclined. So for a child object, the horizontality is not measured with a spirit level, it refers to its parent. Sorry if that's a little bit abstract, but you will see the applications are quite simple to understand. Blender offers us an overlay to visualize the family links. If you go to the Overlay menu, if the Relationship Lines box is checked, you will have a black dotted line displayed between two parented objects, and that allows us to check the hierarchy with the 3D viewport. So these are the main principles of parenting objects in 3D. To go further, you should know that a child can also be a parent of another object. And vice versa, a parent object can itself be a child of another object. We will therefore be able to create a whole family, and this is what we call a hierarchy in 3D. And it is with this principle that we will be able to create mechanical systems or character skeleton. So to illustrate that, we first need to clean this up a little bit, clear parent rotation, and I'm also going to shift my child object over here. So what we're going to do is we're going to build an arm system. So we are going to say that this sphere is the shoulder and that the cube is the upper arm. So I'm going to modify the cube a little bit like this in order to make it look a little more like an arm. Now if I rotate the upper arm, we can see that the origin is misplaced. The arm should revolve around the shoulder and not around itself. So we are going to move the origin, as we already did in previous videos. So for that I go to the small option menu here and I check the origin box so that the transformation will only affect the origin of the object. And then we move the origin roughly to the center of the shoulder like that. Don't forget to turn that option off. And now the upper arm is rotating nicely around the shoulder. When we create hierarchies, it is important to name our objects correctly, with name that makes sense, so it will be easier to select item when the hierarchy will become complex. So we're going to do that right away. This object is going to be the shoulder, and this object is going to be the upper arm. Then we are going to create the elbow, which is going to be a sphere. So we can simply duplicate this sphere here with Shift+D, and with a middle mouse button, by dragging the mouse towards the y-axis, we can constrain transformation along y-axis. So let's position the sphere at the end of the upper arm. And I name this object correctly in the property editor. Following the logic of a human skeleton, the elbow is a child of the upper arm. So we're going to do that, but for this time we're going to use another technique faster than going to the Properties editor, Object Properties tab, looking for the eyedropper, etc. So for that we need to select the child object and the parent object, being careful that the object which must become the parent is the active element, i.e. the one outlined in light orange. Then we go to the Object menu, Parent, and we choose Object. And here we go! Selected object becomes child of the active element object, so here the upper arm. Then we will create the forearm, so we can duplicate the upper arm. So I hit Shift+D, middle mouse button to constrain along y-axis, and I place the object at elbow level. We name it correctly. And that's it. A small thing to note: when you duplicate an object, the duplicated object inherits all original object's properties. And so, since having a parent is an object property, the forearm and the upper arm have the same parent, therefore the shoulder. But we want the forearm to be a child of the elbow. So we will simply parent the forearm to the elbow. And since a child can only have one parent, it will automatically loses the relationship with the shoulder. So we're going to do all that, and this time we're going to use a little shortcut. So we do as before, we select the forearm and we select the elbow, being careful that the elbow is the active element. And this time, rather than going to the menu, we can just hit Ctrl+P, and there we will choose the choice called Object. And as you can see, the object shifts. Why is that? This is because the object lost its affiliation to the shoulder, so it came back to the center of the world on the X and Z axis. On the other hand, it retained its position on y-axis because when we shift the forearm on y-axis, we set a value of its own. So we are going to cancel what we have just done. We start again with Ctrl+P, and this time we choose Object Keep Transform. We will come back to this at the end of the video, but remember this option is better. And so now we set the forearm child of our elbow. If I rotate the elbow, we also orient the forearm. Similarly, if I rotate the highest object in the hierarchy, that is to say the oldest object in our family, which is the shoulder, the whole arm is rotating. On the other hand, if I orient a lower part like the elbow for example, I can bend the arm without influencing the older element of the hierarchy. Let's continue by duplicating the forearm, which I place here. I deform the object a little to create a hand. I rename this object right away, and I will parent it to forearm by doing as before. Ctrl P, Object Keep Transform. We did a hand, now we need to create fingers. So let's duplicate the hand, place the object here, deform it a little, make it smaller, and say it is the first joint of a finger. So I name this object, it's going to be the pinky, and I add _1 because the finger is composed by 3 objects. Then let's make this object child of the hand, and duplicate it to make the second pinky joint. As before, we make it child of the first joint, and we start again to have the 3 joints, and rename the last one pinky _3. So here it is a finger skeleton. I can articulate each joint. I can reposition the whole finger, enlarge it a little bit. By just transforming the first joint, all the children will follow. What's great about hierarchies is, if I duplicate these 3 items, I'm duplicating what's called a branch of the hierarchy. And inside the new branch, this object, which is the ring finger 3, should have been a child of this object, the pinky finger 2, since it is a copy of pinky 3. But when you duplicate a branch of hierarchy, Blender understands on its own that the parent of ring finger 3 must be the copy of pinky 2, so the ring finger 2. So in other words, by simply duplicating this branch of the hierarchy, I have my second finger perfectly set up. I can enlarge it a bit since it's going to be the ring finger, and we rename everything correctly. So the first joint, the second, and the third. We're going to make a third finger, so I select this whole branch, I duplicate it, and we're going to say that this is the index finger. Actually, we're going to make a hand with just 4 fingers. So this object is index 1. This one is index 2. And this one is index 3. Obviously, each first joint is indeed a child of the hand, because the property has been duplicated, which can be clearly seen with the black dotted lines. Each finger is indeed connected to the hand. Then, let's make the index finger a bit smaller. And we're going to do the same for the thumb to complete our skeleton. So let's duplicate that branch, position it, and then rename each joints. Here I took the third element, so I name it thumb_3, and we end with the second. And here we have all our fingers. Each is independent. I can articulate all parts to start to pose fingers, like that, in any pose, just to show you the principle. And if I orient the hand, all the fingers will follow. And our hierarchies start to be interesting. We could represent this hierarchy in this way, like an organization chart, and if we wanted to continue creating a character skeleton, we would add the rib cage, which would be a parent of the shoulder. We would add the neck, which would be a child of the rib cage, the head, which would be child of the neck, the hips, which would be parent of the rib cage, etc. Let's start to play with our structure. I can orient my shoulder to rotate the whole arm. We can bend the arm, orient the hand, and so on. I think you understood the interest of parenting concept, which allows us to influence a whole descent of objects by transforming only one object. Here, I only transform the shoulder. Rather than having to select everything and rotate on the entire selection, it's super practical. But then, what if I want to modify an object without influencing all the descendants? For example, change the size of the hand a little bit, because let's say it is too small or too big. If I scale it with the S key, obviously all the bottom of the hierarchy is also scaled. Fortunately, there is an option to be able to modify an object without influencing the bottom of the hierarchy. Do you remember we can transform an object so that it only affects the origin? Well, we can also, in the same menu, say that we want to make a transformation that only affects the parent object. So if I check this box, I will be able to make a deformation, I will be able to move the hand a little bit, etc. I do pretty much anything. It is just to show you that you can transform an object without affecting its descendants. So, I now uncheck this option, and there it becomes normal again. If I do a transformation on the hand, all children will inherit the transformation again. So now you know the basics of creating a 3D skeleton. Blender has a much more powerful system for creating hierarchies of skeletons. This is called the armature, the famous armature that can be created here. Well, an armature works pretty much on the same principle, except that instead of using primitive objects, as I just did here, it uses objects specially designed for that, and which are simply called bones. And since these objects were designed to create mechanisms, bones have a whole bunch of properties and dedicated tools that will really make your life easier. We're going to use armatures later on, but I wanted to show you the principle of parent relationship because it's really the fundamental concept of any 3D mechanical structure. Come on, we're going to continue a little bit longer to explain things about the family relationship. Now we will see what happens if we decide to delete a relationship. For example, we are going to say that we no longer want the hand to be a child of the arm, whatever the reason. So to do this, we can go to the object properties, and in the relation panel, we will be able to simply delete the parent property, thus deleting the relationship with the forearm. And there, look! My object has moved. In fact, it has been reinitialized in a way, or rather we are going to say that all the transformations values which the hand inherits as a child of the forearm, location, orientation, and scale no longer operate, and therefore it resumes a state defined only by its own transformation values. And besides, if I, for example, set all the location properties to 0, the hand is now placed at the center of the world, and no longer centered at its old parent's spot. Same for the rotation, I set everything to 0, and normally the object should be straight again. But if you want to remove a parent link while keeping the object as it was when you break the link, there is another way to do it. So I'm going to undo everything I just did. Why are my fingers there? Ah, it was a little bug. So now rather than deleting the link directly here, I can go to the object menu, then parent. And then there we can just clear parent. That will give us exactly what we just saw earlier. So the object's position is going to be reset relative to the center of the world. But if I use the clear and keep transformation option, the object will lose its parentage, but transformations of its parent will be applied to the object's transformation values. We can see this in a very concrete way if we memorize the transformation properties of the hand in this panel. So we're going to do it thanks to the magic of editing. And now I do a clear parent keep transformation. And there, we can see that the values have changed. This is because Blender actually adds the parent's transformation values to the child's transformation values. So now the hand is kind of orphan. So if I move the hierarchy, the hand is no longer influenced at all, but on the other hand it has kept the position, rotation, and scale of the time when it was a part of the arm family as the forearm child. Let's see one last thing. I'm going to undo what I did so that the hand becomes a child of the arm again. And if I go to the outliner, what do we have? I only have one object, the shoulder object. On the other hand, I have a little icon here with 16 written on it. That's mean the shoulder item doesn't only represent an object but a whole hierarchy, of which the shoulder is the older element of 16 children. We also find the icon that represents meshes, so the icons tell us that these child are meshes. If I expand the shoulder item, I will find the upper arm which has 15 little and great little children. And so on. You can see that the outliner organizes our project according to the parent hierarchy. This way we can develop the whole hierarchy. We can therefore select elements of the hierarchy using the outliner. For example, to select the whole hierarchy at once, I can move to the oldest object, the shoulder element, and then I right-click and hit Select Hierarchy. And all the little children are selected. To select only some children, I can do the same thing from the elbow, for example, that will select the lower branch from the elbow. So let's click again on Select Hierarchy, and that will select the entire descent of the elbow. And voila! I think there are still things to say about parenting object in 3D, but we'll talk about it on the video on the armatures. Thank you for following this somewhat technical tutorial. See you soon in the next video.